Hi everyone, my name is Kelly and I'm a graduate student in the Department of Physics and Astronomy here at Dartmouth College. I'm really excited to work with you all this year and I can't wait to get started talking about some science. First up, a little bit about me. Some of my hobbies include baking, knitting, wood carving, and playing tennis. Growing up in a small town, these were all great ways to pass the time, but even more so was looking up at the sky at night. It was this love for looking at the sky in combination with my passion for building and making things as well as doing math that brought me to the current field I'm in today, which is called space physics. Most of the time we think of the space between, say, the sun and the earth as being empty, but this is actually not quite the case. On this bright sunny day, it's more than just sunlight that's coming towards us. The sun is also sending a continuous stream of charged particles towards the Earth called the solar wind. As these charged particles make their way from the sun to the Earth, some of them get trapped in Earth's magnetic field. You can see these magnetic field lines with the little iron filings trapped along them there. Some of these particles remain trapped, while other particles, after some type of magnetic disturbance, or what's called a plasma wave, they precipitate down into the atmosphere. While it can be fine and even exciting, some of this precipitation causes the aurora that you see at the north and south poles. Some of the higher energetic precipitation can be dangerous for satellites, astronauts, and even damage the ozone layer. So it's important that we understand what's causing this precipitation and what are the mechanisms for how it happens. Our group studies these charged particles and this precipitation with atmospheric balloons, satellites, and in-lab measurements. Currently, we have a satellite that we're working on that we hope to launch into low Earth orbit later this year. Before sending any equipment into either the upper atmosphere or into space, all of the hardware has to undergo rigorous testing to make sure that it's going to survive the journey. For example, you would use this thermal chamber to test the extreme temperatures that the hardware will experience, or this vacuum chamber to test the low atmosphere environment that all of the hardware will be in. A great place to study the precipitating particles are Earth's magnetic poles. Here's what's left over of one of our scientific instruments, or payloads, that we launched in Antarctica. This payload was sent up over 30 kilometers into the sky, stayed up for about a month collecting data, and then crash landed on the ice to be recovered by a team of professionals and brought back to our lab bench here. While exciting, building balloons and satellites can be very time-consuming and expensive. One way that we can study Earth's radiation belts without having to actually go to space is with this device right here. This is a lightning generator. What this does is create a spark of charged particles just as strong as you would see outside during a thunderstorm, but here in the lab, under conditions we can study and control, allowing us to recreate some of this wave and particle phenomena, but on a much smaller scale. Thanks everybody, looking forward to working with you this year.